This presentation is geared towards providing an overview on project-based learning, and I will be giving a practical example on how this instructional approach was used to teach mobile app development to K-12 students in a blended learning environment. Project-based learning is a model that organizes learning around projects. In the literature, the terms problem-based learning and project-based learning are used interchangeably. Yet, problem-based learning focuses more on helping students achieve or arrive at a solution to a problem, whereas project-based learning instruction is instruction organized around making a product, task, or service. Thomas sets 5 criteria for project-based learning projects. These are: projects are central, not peripheral to the curriculum. Projects are focused on questions or problems that drive students to encounter and struggle with the central concepts and principles of a discipline. Projects involve students in a constructive investigation. They are student-driven to some significant degree. And finally, projects are realistic. They are not school-like. Roots of the idea that projects represent learning by doing are certainly not new and can be traced back to more than a century ago to John Dewey and his followers. Project-based learning are based on constructivism learning theory that posits that learning should be learner-centered, knowledge-centered, assessment-centered, and community-centered. Project-based learning is also based on constructionism learning theory that states that individuals learn best when they are constructing an artifact that can be shared with others and reflected upon. There are several benefits to employing project-based learning in courses. These include affording students the opportunity to gain knowledge and skills through different activities in a variety of domains, enabling students to develop dispositions or tendencies to act in a certain manner in addition to developing feelings such as self-esteem and confidence, and having students produce artifacts that represent answers to questions that have the potential to motivate students and help them better understand subject matter content. In this slide, I present some common features for implementing project-based learning. For the sake of time, I'm not going to go over each of the features, but whenever you do have time, please take some time to read through these features. Finally, there are some challenges that are faced by educators when implementing project-based learning. These are that teachers need to be open to its constructivist nature, they need to be skilled in taking a student-centered approach with their students, they need to have the motivation and the abilities to adopt a new instructional strategy, and finally, they need to be confident in managing the project-based learning activities. Moving on to a practical example of how project-based learning was introduced to motivate and engender deep, meaningful, and hands-on learning of computer programming in a K-12 context, I will now present a course I recently developed in collaboration with a company called MobGeek, who are experts in delivering computer programming courses online. So we worked together on finding an ideal instructional approach that would cater to the K-12 students, and we decided to use the project-based learning approach. A range of instructional components were used, such as authentic text, collaborative work, cooperative work, demonstration, and guided practice, to name a few. For content sequencing, we used procedural and scaffolding, and we decided to use the Titanium framework to teach the kids how to develop mobile apps. So here are the course learning objectives. The objectives were to develop critical thinking, creative thinking, collaboration, and communication skills. We also wanted to develop information literacy, media, and technology skills. We wanted to develop life skills, that is, open the doors for the students for future career opportunities. We wanted to engage the students in finding real solutions to real problems. We wanted to teach the students how to learn how things work by creating digital content. You have to keep in mind that these are all native digitals, so they should learn to create digital content, not only to consume digital content. We wanted them to learn all of this by doing. And finally, we wanted to teach them how to develop a mobile app using the Titanium framework. So there were a variety of learning tools and resources that were used in this course, which I will be showing you. But here are some. We used the MobGeek site in order for the students to access the video lessons. We used Google Hangouts for synchronous discussions with the Titanium instructor. All of the course is currently being hosted on the Moodle. It's an 8-week course, and it's also a blended learning course, as I mentioned earlier. Students are doing group work. They're working in pairs or they're working in threes. We use Dropbox in order for students to store and share app code files. We use Blog WordPress for students to develop their web quests. The internet was also used for students to conduct research. And finally, we use slides, videos, music, multimedia in order for students to showcase their final projects. That is the apps that they're going to build, which will be showcased during the last week of the course, that is week 8, in a face-to-face session. So finally, I want to show you the Moodle site where the course is being hosted. And here you can see we have a discussion forum for general doubts, for announcements. We have here our wiki where the students will be contributing towards building programming terminology. This is a collaborative and collective activity. The course has been divided in 2 weeks, and each week has its sets of activities and tasks for that week. Here they can access the video lessons, which are hosted on the Mob Geek site. Once they finished watching the video lessons for that week, then they have to do the multiple choice exercises. And finally, here is the link to the web quest, which they will be developing during the course. We provide a model of the web quest. Web quests usually contain an introduction, a task, process and resources, conclusion, and credits and references. And the main objective of the web quest is to get the students to decide what app they want to build and to justify what app they're going to be building. Then during workshop 2, where we're going to be working on design and wireframing of the apps together with the students, they will go on to programming their apps during weeks 5 and 6. They will also be working on their presentations to showcase the apps they built, which will be happening during the last week of the course. Thank you for watching this presentation. I hope it has been informative.